This is the question number 3. This is analytical geometry question. The question says in the diagram below, P, Q, R, and S are vertices of a parallelogram PQRS. The x-intercept of PQ is T. QN cuts the x-axis at M, and the angle at T angle MQ is equal to beta. So this is the information of the sketch. So the first question he asked, determine the gradient of QR. So first of all, this is an easy question. We need to find the gradient of QR. So I'm going to use the formula here, y2 minus y1. So the gradient of QR is going to be a gradient of QR is equal to y2 minus y1 and divide by x2 minus x1. This formula you're going to find in your information sheet. Now I'm going to substitute all of these value. So this is between Q and R. So -3, my y2 is -3, and the y1 is -2, -2 over x2 minus x1. So the x2 is -5 minus, and x1 is gonna be a 2, so the -2. I use the calculator, so my answer is gonna be equal to 1/7. So this is my first question answer. Second question says calculate the size of beta. Just remember beta is here. We need to calculate the size of beta. We have the gradient of QR, which is 1/7. So the line gradient is the same. So so if I'm gonna angle of inclination, I'm gonna use here, you're touching the x-axis, so that's gonna be my theta. And then after that, when I find that angle, and that's gonna be a vertical opposite, that's gonna be size of beta. Have a look here. So I'm gonna say tan theta angle of inclination I'm using, so 1/7 equal to the gradient. Now I need to find the theta. That's gonna be tan inverse 1/7. Use my calculator. The answer is gonna be 8,13 degree. Now so therefore the beta gonna be is equal to 8,13 degree, because vertical, I give the reason, vertical opposite angles. So vertical opposite angles, they are equal. So here this is going to be a vertical opposite angle here. This is theta is here. This is my theta. So this is my theta, vertical opposite angle. So this is my answer. Beta is 8,13 degree. 3.3, determine the value of alpha. So here I need to first find out the equation of PQ, because this point because this point T lies on this line PQ. So I need to find the gradient of PQ. I'm going to find the straight line equation, which is y is equal to mx plus c. Then I'm going to substitute T to find the coordinates of A, which is x-intercept. So the gradient of PQ, I'm going to use again same formula, y2 minus y1, x2 minus x1. So this is, I'm going to find the gradient between these 2 points. So I'm going to use the formula y2 minus y1. These are the points of P and Q. So -3, this is my y2 minus y1 is 2, -2 over x2 minus x1, which is -5 minus 0. Now I use the calculator, answer is 1. Now I'm gonna use the equation to find the straight line equation, y minus y1. I like this formula, mx minus x1. I'm going to use this formula. This is always at the back of your information sheet. I'm going to substitute the point here. One of these point I can substitute p here. So sub this one into this equation is going to be y. This is x and y. Minus 2 is equal to the gradient we got 1 and x minus 0. So therefore my equation gonna be, this is I multiply inside become x and this becomes 0. So obviously negative 2 I pull over this side become positive, so the x plus 2. So this is the equation of the straight line. Now I'm going to substitute this t, coordinates of t, which is a, x value 0, y value sorry, the x value a, the y value 0, into this equation. So it's going to be a 0, place of x going to be a plus 2. Now therefore the a is going to be equal to negative 2, because positive 2 I switch over this side become negative. So I got the point of a, negative 2. Must remember I substitute t, x is a, y is 0, into this straight line equation. And 3.4, determine the coordinates of s. There's many ways to solve this question. We need to find the coordinates of s here. This is a parallelogram, but remember p q r s is a parallelogram. So there's two ways to find this, solve this question: by inspection, or you can use the midpoint as well, because the both diagonals they bisect each other, and then I can find the midpoint of the one of the diagonals, and then I can equate midpoint, or I can by inspection I can solve this question. So answer will be the same. You can see this is a 2-mark question, so I rather go by inspection. So by inspection basically very easy, because uh, how you get to from q to r. So the negative 5, uh, so the horizontal change, this is x value, if you add 7 become 2. Negative 5 plus 7 is 2, and vertical change is negative 3. If you add 1, positive 1 is it will give you negative 2. So I must do the same thing here from p to s. So 0 plus 7 is going to be 7, and 2 plus 1 is going to be a 3. So the coordinates of s going to be 7 and 3. So negative 5 you add 7 and become 2. Negative 3 you add 1 become negative 2. But remember, if you add horizontal, then arrow must shows to the right, and if you add vertical, then arrow must shows upward. And exactly we're gonna do this one 0. So you're gonna add here you 7, and also gonna add 1. So 0 plus 7 is 7, and 2 plus 1 is 3. So these are the coordinates of s by inspection. You can use by midpoint theorem also. You can apply the midpoint formula also if you want to, but that's a longer way because it's only 2-mark question. 3.5, show that the diagonals of PQRS bisect each other. So we need to show that diagonals bisect each other. So which means the diagonal PR and the second diagonal QS, if their midpoints is equal, they meet each other here, then which mean the diagonal bisect each other. So the midpoint of PR, I'm going to take the midpoint of PR, that is 1 and 0. I substitute into the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now I'm going to take the midpoint of QS. Midpoint of QS. So the midpoint of QS, these are the points of Q and S. Remember earlier we found the points of S. Now, so x1 plus x2. So this is my x1, negative 5 plus 7 divided by 2. And other side y1 plus y2, negative 3 plus 3 divided by 2. You cannot do this one. If you choose this is your x1, then this is your y1. If this is your x2, then this is your y2. You cannot do this one, this is your x1, and then you decide this is your y1. That's wrong. If this is x1, this is y1. This is x2, this is y2. I substitute into the formula, and I'm going to use my calculator. The answer is again 1 and 0. So that means the coordinates, the midpoint of PR is 1 and 0. The midpoint of QS is as well 1 and 0. Therefore, I can say the midpoint of PR is equal to the midpoint of QS, and which is 1 and 0. Must remember. So now I can say the diagonals bisect each other. Therefore, the diagonals bisect each other. 3.6. Show that triangle PQR is an isosceles triangle. So this is orange triangle PQR. We need to show that this is a isosceles triangle. So now, must remember isosceles triangles, the sides are equal, and so I can take the distance of PQ and the distance of QR. If these two distance sides are equal, then I can say this is P, then I can say PQR is an isosceles triangle. So I need to PQR. So this is a green triangle. So I'm gonna take the distance between PQ, and I'm gonna apply the distance formula QR. If these two sides are equal, then I can say this is a isosceles triangle. So I apply the distance formula here, PQ. These are the coordinates of P and Q. X2 minus x1 square plus y2 minus y1 square, and this is my uh, after the distance formula I apply, this is my answer. Now I'm going to take the q distance between QR. So the distance between QR is same. So now therefore uh, PQ is equal to QR. Now PQ is equal to QR, so I can say both sides they are equal. Therefore, uh, triangle PQR. Sorry, the triangle PQR is an isosceles triangle. They be proved. 3.7. PSRQ is a parallelogram, but which other type of quadrilateral is it? Give a reason for your answer. So now must remember the parallelogram family. We got rectangle, rhombus, and square. So if you look square and the rhombus, the diagonal bisects each other at 90 degree, and the rectangle corner angle is equal to 90 degree. And also must remember, if you look at the PQ is equal to QR, so both pair of a parallelogram with two adjacent sides equal in length is a rhombus, because this side is going to be equal to this one. So I can say this is a rhombus. So this is a rhombus. Now I can give this reason, or I can apply the perpendicular formula. I can take the gradient of PR, multiply the gradient of QS, and if answer come equal to -1, which means they are bisect each other perpendicular, then also shows this is a rhombus. Let me show you how to do. So I can say rhombus parallelogram with one pair adjacent sides equal. Parallelogram with uh, one pair adjacent sides equal. Adjacent sides equal. So you can use, but this is a 2 mark question only. If you want to, then I can also find the gradient of QS and the gradient of PR, and then you multiply this both gradient, answer must be equal to negative 1. Must remember that perpendicular formula, and when you multiply two gradient and answer is equal to negative 1, which means they bisect each other at 90 degree. They bisect perpendicularly. Last question, calculate the size of angle Q. I can use exterior angle of triangle to find this one. Always they ask this question, this is a must question. This is the triangle we have. Say for instance, I'm gonna highlight it in orange. So this is the triangle I have. Now if I can find this angle here, and then I have already this angle, so exterior angle of triangle I can use. This is a must question. Always they ask exterior angle of triangle. Then I can find the angle Q here. Let me show you how to do. So we got this triangle, orange triangle. So I need to find this one. So I've got this one, we already have beta. So I got the gradient of PQ. I need to find the angle of inclination here. Don't forget, we got beta already 8,13. We earlier found. So beta we have 8,13 degree, and we have MP, the gradient of Q PQ we have already. So the gradient of PQ we have, there the gradient of PQ is 1. So now I'm gonna angle of inclination. So I need to find the P angle TM. Just remember this angle I need to find. Must remember PTM. This angle I need to find. That's I'm gonna say the tan inverse angle of inclination, tan inverse of 1, and that's gonna be a 45 degree. I use my calculator. Now so I go to 45 degree. So this is we have now angle T, PTM, we have this one 45 degree. So these two angle if you add equal to this, the exterior angle of triangle. So if I minus from this angle beta, then it will give me angle Q. So therefore angle Q 45 degree minus 8,13 degree exterior angle of triangle. This is my final answer.